Evaluating the logic of table order, particularly in electrical codes, requires careful consideration of several key factors. These factors directly impact the usability and clarity of the information presented, and ultimately how effectively the tables can be applied. Firstly, clarity and interpretation are paramount. Tables should be organized in a manner that ensures ease of understanding. The progression of information within the tables and between multiple tables should follow a logical sequence, prioritizing the presentation of the most crucial or pertinent information initially. This approach minimizes ambiguity and streamlines the interpretation process for the user. Secondly, usability is a critical aspect. The arrangement of tables should actively facilitate the user's task. For instance, if a common task involves comparing data across different voltage ranges, the table should ideally be structured to support this comparison directly. This might involve arranging tables in ascending or descending order of voltage, or providing clear visual cues to distinguish between voltage levels. Thirdly, adherence to precedent and established standards is important. Within the electrical industry, specific standards or conventions may exist for organizing tables related to electrical voltage ranges. It is beneficial to assess whether the existing table arrangement aligns with these established norms. Consistency with industry practices can reduce confusion and promote wider acceptance and understanding. Fourthly, the context and usage of the tables must be taken into account. The perceived logic of a table's order may be highly dependent on its specific application and the context in which it is used. Therefore, it is essential to understand the intended audience for the tables and how they will typically interact with the information. This understanding should inform the design and organization of the tables to maximize their effectiveness. Evaluating table organization can involve a deeper understanding of what is considered an acceptable level of risk and how to apply it based on relevant safety factors. For example, understanding the dirting factor of a conductor that's 90 degrees Celsius in an ambient temperature that exceeds 30 degrees Celsius. Additionally, if the conductors are installed in a conduit on top of a roof, you would need to consider an additional temperature adder. You would then consider the weakest link to determine the overall rating of the conductor. You might consider the log rating on the circuit breaker, which is commonly rated at 75 degrees Celsius. Ultimately, the conductor ampacity would be based on the lowest temperature rating. In summary, these factors, clarity, usability, standards, and application, are crucial for determining whether the arrangement of information in tables is sensible and easy to follow.